What is partition function in statistical mechanics? Today our lecture is what is partition function, and we will see further about the partition function, that history of partition function, role of partition function in statistical mechanics. Further we will see definition, example and calculation, and frequently asked question about partition function. So the question is, what is partition function? In simple words, partition function is a mathematical function that sums over all possible microstate of a system. It allows us to calculate various thermodynamic properties. So in simple words, this is a mathematical function. It will allow us to sum all the possible microstate. These states we will study in further lecture and calculate these microstates. After this, we will see about the various thermodynamic properties. For example, these thermodynamic properties include, like, to calculate the quantities like internal energy, entropy, free energy. We use partition function, and all these values are further explained in this lecture in step by step with example. After this, we see it enables to predict the macroscopic properties of complex system based on the behavior of their microscopic constituent. So these are the two examples which shows that the partition function, and how we study these partition function and calculate this partition function. We will see all these things in further lecture. So before starting this lecture, we will see about the history of partition function and know about the scientist who gave this theory. So the scientist who gave this theory was named as Simon Laplace, worked on partition function and introduced the partition function in statistical mechanics. In further, Boltzmann and different scientists worked on partition function. So before finding the value, first of all we will know about the role of partition function in statistical mechanics. So the partition function serves as the key to unlock information about the system thermodynamic behavior. It encodes the statistical probabilities of different microstates, enabling us to compute macroscopic properties. This is very important phenomenon, that when we study about the microstates, it tells us about the macroscopic properties, and we also study about the thermodynamic behavior like internal energy, entropy, and further values will also study in this topic. So before using partition function, first of all we will define what is partition function. So in simple terms, this is a mathematical function used to describe the statistical probabilities of all possible microstates in thermodynamics, and further we will find the statistical probability of microstate in thermodynamic system. For example, let's consider a simple system of 3 spin. This shows the spin -1/2. This shows the particle like electron placed in a magnetic field. Each particle can have two possible states. So this is the term probability of all possible states. So these are two basic states of each particle. Here we will take about the state of an electron, which shows the spin up. In spin up we take upside arrow and take positive value, and for downside we take arrow in downside and take negative value. Further we will see about the another example which explains the partition function for the system. For example, we have a system whose microstate can be represented as combination of spin configuration for each particle. Let's upward side, this shows up spin, downward side arrow show down spin. To calculate the partition function for a system, we take the possible microstate of the system, which can be shown that if we have three particles, their microstates can be shown that all three particles have possibility that they, or a probability that they have 3 spin. And if we take further move, this shows that 2 particles have possibility of upward spin and 1 shows the possibility of downward spin. So this is the probability. For example, if we take a particle and find their probability, this is the probability, and we will see all the combination which tells us about the upside or downside spin. In further we see the center particle which has downward spin, and if we further move, the first particle have downward spin and other two have upward spin, and further combination we will see all the spin motion. This shows that all the particle have downward spin, and first show all the particle have upward spin, and in few steps we see all the spin motion of these three particles in upward and downward position. Suppose the energy associated with each sign up state is E, which shows upward spin, and the energy associated with each spin, E, is downward spin. These are the energy of microstates. As we studied earlier, these microstates tell us about the macroscopic properties, and macroscopic properties given by all these microstate, and we sum all these microstate values like this. For example, we have energy upward spin, this shows upward spin, and further we see up and down, and different particle have up spin and down spin. These two show down spin, this show energy in upward spin, and we see all these combinations here which shows the energy of a particle and their spin in all are in upward and these all are in downward spin position. This can be calculated by the partition function. So the question is how we can calculate partition function, because this is the energy, and how we use this energy to calculate the partition function we will see in further that how to calculate partition function for a system. Suppose the partition function z given by sum of Boltzmann factor for each microstate. So microstates are given and their energy is also given. Here B shows the Boltzmann constant and Z shows the partition function. Partition function is represented by Z here, and B shows the Boltzmann, and energy of each particle and their spin can be added here. So first of all we take exponential function and we take partition function spin and add up all these values, and further we take spin, these spin which shows that upward spin and downward spin. These spins are the combination which we have already seen like this. Here you can see we take all these combination upward, then upward downward and upward spin, and these combination and all these combination values added and put here. Here you can see first combination, second combination, and further up to so on. Already all the function which we have and their spin can be added till last value, and they can be added to get the partition function which is denoted by z. So when we put all these values here, we can get our result here B, whose value is given, and B is the Boltzmann constant and T is the temperature, whose value will be put here and get the answer. Question, you can see here that how is the partition function represented mathematically, what is the significance of partition function, and how does the partition function connect statistical mechanics to thermodynamics. These are the questions you can read here and get your answer. Further, if you have a question, you can ask in the comment section and get your question. So for further lectures, please subscribe this channel and like this video.